So start with the land acknowledgement today. One of the things living in Calgary is you get on the weather roller coaster, but for all the complaining people do, I do love living in Calgary, and I don't care that it's going to get about 30 degrees colder than today in the next few days. So the Creator gifted us with this land that we're blessed to care and to share and care for together. The Calgary Catholic School District acknowledges that the land we gather on, Mokinstis, is the ancestral territory of the Siksika, the Siksika, the Kainai, the Piikani, and the Amskapi Piikani. We acknowledge all First Nations and the Métis of Treaty 7 lands, the Tsuut'ina, the Ithkabay, which includes Bearspaw, Chiniki, and Goodstoney. The Calgary Catholic School District commits to advancing respecting treaty laws and humbly walking alongside First Nations, Métis, and Inuit. We recognize all who live, work, and play on these lands and who now call this place home. Today is the feast day of St. Thomas Aquinas. He is the doctor of the church. He lived around in the 13th century. He's the patron saint of academics, schools, universities, learning students, and pencil makers. And I thought, how fitting on a day like today to be the feast of okay, I have a bit of an issue going on with my computer, which is kind of annoying. So I hope that that does not impede our progress. Oh my gosh. So everything we do is everything that we do is built into our priorities. So today what we're doing is we are going to be talking about the student success priority. So where did this all come from? Part of my work has been to go out and support teachers, and often I hear these comments coming from teachers. I made the test easier and removed questions, but now their grades are inflated. Grades always drop in grade 9. Of course, this mark is reasonable. I accommodate, but the kids didn't even try. We have students who are below grade level. How can I possibly assess them? And so I urge you guys to take a look and see if any of these resonate with you, and if there's, I'm sure I've missed some. So do let me know if I have. You can let me know in the chat. But this was something that I was hearing, and my colleagues in the math and social and ELA world were also hearing, and we were thinking, boy, like this is not something to take lightly, right? Like I think that there's a lot of this kind of in the district, and it's been a bit of a challenge. So we recognized this, and we sort of did a bit of digging, and we recognized that in order to try and support all our students, we have to accommodate. And sometimes what we were noticing is that we weren't really sure what accommodated meant, what adapted meant, and we borrowed this slide from our DL team, and recognizing that the accommodated program is kind of where we live as teachers. We want to do our best to help all our students get across the finish line, and we want to help through that learning process by providing scaffolding, by differentiating. And often the easiest way, or the way that many teachers can do that, is by offering less questions. Now, that's great, but sometimes what we noticed is that there became a bit of a conundrum. Sometimes by removing questions, teachers either removed all the high complexity questions or they removed all the low complexity questions. And by doing so, it sort of led to inaccurate grades. So that was one issue we were running into. And another issue we were running into was that many teachers had lots of variations of exams. So they had 4 or 5 different assessments and to try and serve the needs of all their students. And at the end of the day, there were 5 different versions of tests coming in, and teachers are feeling, well, what's accurate? Like, does an 80 on version C actually mean an 80? Well, what about the kid who got 65 on version B? Like, are they actually performing the same? Anyway, so it's challenging. And then in junior high, that's a lot because there are so many complexities in that classroom. And then as students move into high school, often classroom teachers just look at a mark. So they don't really understand maybe some of the complexities that that student had faced, and so they get popped into a class that they may not be necessarily ready for. Anyway, so there was a lot of that going on, and so how do we rectify that? And so one of the things that we've been working on here, and we've been trying to wrap our minds around, is looking at content through the progression of skills. So knowing that some skills are at the beginning level, some skills are merging, some skills are proficient, and certainly some skills are mastery. And we often look at Bloom's taxonomy to think about how those skills might be sort of placed along that continuum. And that's all well and good, but how does that all kind of connect to our program of studies and the task at hand, which is getting grade 7 students, grade 8 students, grade 9 students, and even high school students through their curriculums from a science lens. So we really are looking for ways to create an access point for our science curriculum for students who have low literacy and numeracy skills. So to do that, I don't have the answer really. Like there's no silver bullet. It's we got to go back to the curriculum and identify the knowledge pieces and think about the sophistication of skills at which that knowledge is to be kind of taken up. So I really kind of think about this as just a reorganization of the skills, or sorry, of the resources we have, and being really just mindful of how we organize those resources to walk our students across and through our program of studies. So let's take, for example, in science, we're tasked with, let's teach students about whatever the case is. Let's say it's photosynthesis. And we think, oh my goodness, how are we going to teach a kid about photosynthesis if they are at grade 2 reading level or that kind of thing? And I get that. So I thought I'd just kind of offer a metaphor. So let's say we want to talk about a car. So one of a low sophistication skill might be to list the parts of the car. It's lower level, student observes, recalls. When we describe the parts of the car, it kind of is more of an introductory level. It might kind of fall under that emerging level along my arrow, which I had in the previous slide, along that continuum. A student might describe what the part does and maybe what it looks like. So the structure and the function of these independent parts. Then they move into a more sophisticated skill. They're analyzing the parts of the car. It's a bit more higher level. Students will describe, or they could describe, how each independent part contributes to the function of the car. So now we're talking about synthesizing, putting ideas together. It certainly has a more complete understanding of what the car does and how the car works. And then finally, a mastery skill, or a really high level or high sophisticated skill, might be to evaluate the parts of the car, which might be, talking about in terms of economy or in terms of efficiency, what kinds of things might you change on the car to make it more efficient so that you could conserve fuel. And for a student to answer that type of question, truly they would have been able to answer the list, the describe, and the analyze parts of the question. So they're still talking about the car. Everyone's dealing with the car, but depending on where the level of sophistication for each student is, they're working at these different sort of parts. Maybe they're just at the listing part. Some of our students might be evaluating, and everything sort of in between. So how does that translate actually into science? So let's look at grade 9. So this is general outcome B, and the general outcome is describe and interpret patterns in chemical reactions. So this is a heavy hitting unit in grade 9. We get tripped up here a lot. Teachers spend a lot of time here. It's important. And so the specific outcome of this is observing heat generated or lost, identifying examples of exothermic and endothermic reactions, and identifying conditions that affect the rate of reactions. So what we really want to be doing is we want students to interpret patterns. We want them to describe the pattern and interpret the pattern, but we do that by offering them knowledge pieces. We show them chemical reactions that are exothermic, so they generate heat. We show them endothermic reactions, which absorb heat. And then we kind of move them along that continuum and say, hey, what happens if we change the surface area? What happens if we do this? How would the rate of reaction change? And all of those pieces, all those knowledge pieces, support the skill of interpreting patterns. And so that's the ultimate goal. And It's not easy. No, I get that. So identifying the conditions is the knowledge, and interpreting the pattern is the outcome. So here's sort of how I imagine this being put along a continuum. So this is general outcome 2, which is describe and interpret patterns. And the specific one we're looking at is observing and describing patterns of chemical change. So imagine this is a stem. Magnesium reacts with hydrochloric acid to produce hydrogen gas and magnesium chloride salts. As the reaction progresses in the test tube, it gets hot. So if we look at some of the questions that we offered the student, we look at the first one, is this physical, is this chemical? Likely you've covered this earlier in this topic. It's an identify type of question. We might ask the kids to draw a picture of a thermometer showing 20 degrees and 35 degrees. It's really important for students to understand that we're talking about heat here. We have to understand how to measure heat, how to track data. This is a great entry-level skill. It's an identify type of skill. Do you know what this is? Can you see? Drawing is also, it can be accessible. So the idea here is that with something like this, all students would start at the beginning and move along and stop where they get stuck. All of these questions actually came to me from other teachers. I have those interactive documents that I have on my Google Drive. I just pulled them from there and kind of massaged them a little bit to sort of fit a little bit better and change the words to make them a little bit friendlier. So the idea here is that we don't have 5 different exams or 5 different worksheets or 5 different anything. It's one, and we all start at the beginning and we try and make it to mastery. One of the things that I've noticed teachers enjoying about this is they can sort of see where a student kind of becomes tripped up, but they can also then support the student in moving forward. And if there's questions about reassessment or I don't get why I'm failing or I don't get why I can't have 100, we can easily point to, well, you sort of are living in the emerging proficient area. For you to be a master, these are the types of questions you have to be able to answer. And these are the ways I can support you to be able to get there. But functionally in your classroom, everyone's working on something at the same time, and it all looks the same. If there's any, I haven't been checking the chat, but if there are any questions, I can't see the chat, so please just interrupt.
No, there's no questions yet, Maria. You're good.
Thanks. So, I just want to take a second. Grade 8 fresh and saltwater systems. This is not, I personally just find this unit hard. I don't really like it. I'm not a geologist. I come from a chem background, so I struggle with this. So I thought I'd just take a minute and have you guys think about, much like we did in the previous slide, what kinds of questions could we write at the different skill levels? So thinking about the outcome, of course, the outcome here is students will investigate, interpret linkages among landforms, water, and climate, a big one. And the specific outcome here is identify evidence of glacial action, analyze factors affecting the growth and attrition of glaciers and polar ice caps. So I'm thinking about, as a teacher, what are some of very entry-level, beginning type questions that I can ask that engage very low sophistication skills to kind of get kids warmed up, but allows many, if not all your students to enter into the conversation. So, you know, I included a diagram here. Could we ask things like circle the glacier? What is melting? Describe, you know what I mean? Like helping prime students to be thinking about, okay, we're going to be talking about temperature. We're going to be talking about freezing. Do all our kids know that snow and ice are in fact the same thing? That they're all under 0? Would it be worth kind of having a conversation about temperature again? Water freezes at 0. It boils at 100 degrees Celsius. So those are the kinds of things I'm sort of kind of getting at. So I will take a minute, and if you guys could take a look and maybe think about what kinds of questions you might ask at some of these different levels. All right. And pause. Pop them in the chat if you'd like, or shout them out loud.
Okay, Maria, I don't see any questions coming into the chat
Okay.
yet, but I thought
All
I
right.
would maybe throw one out there. What about sorting? Like for some of our kids that maybe don't have the language, could sorting be a place to start where we're sorting images?
Absolutely. And so, yes, absolutely. Why couldn't we sort by warm or cold or hot cold, right? And those are nice, those are good words. I think they're those really simple, like consonant, vowel, consonant words. So it's a really good place to start. Sorting can absolutely go in there. And it's always a good time, even for our strong students, to kind of think about that. They don't have to, they can sort images too. Why not?
And maybe even like layering different environments into your images can get some more connections being made to that. Oh, okay, so in this environment this is what we'll see, and in this environment this is what we'll see, even though it's not necessarily explicit in this outcome.
That's right.
Nicole had a question. Her
Sure.
question was, what is a glacier? Where are glaciers found? Talking about the path that glaciers would take.
Yeah, and so and that's kind of what I was hoping we would kind of generate some questions about this outcome. What is a glacier? What a great place to start. That is an awesome starting place for strong kids, weak kids, and every sort of kid. Now, here's the thing, and I should have mentioned this, and I was remiss to do so. We teach this way. Most teachers start at the beginning, they generate conversation, and we kind of get everybody on the same page, and then we kind of begin to teach towards the outcome. But when we assess, we often are assessing right at the very end. We are assessing the outcome at the proficient mastery level that we often leave many students behind. And so I'm suggesting, I'm not saying anything, I'm just suggesting maybe we could rejig our assessments a little bit to include some of those emerging questions to kind of get some kids on board and hopefully move them along a little bit. I love that. Those are awesome.
Okay, you have some more.
Awesome. Okay, you know what? Let me switch out of this window. Let's see what else we got. I love it. All
Okay,
right.
so are you going to the chat? Is that what you're doing?
I'm going to the chat.
Okay, yeah, because Jonathan had a question and then Christina also had a question. They're really great ideas.
Explain movement flow of glaciers across land and through water. Awesome. So explain could be both emerging and proficient, I'd argue, Jonathan, but yeah, that's good. This might be a beginning or emerging question. How would a glacier grow? Yes, it could be. It's, you know what? I love that because depending on how we have taught that, when we think about how a glacier grows, we have to connect it to climate. We have to connect it to weather, to temperature, right? Those are great. And sometimes we jump way at the end and we haven't even kind of given kids a bit of context. These are awesome. Can I heart them? Let me do that right now. And so it's not, there's no magic bullet in helping with differentiation. Really, there isn't. The idea is that we just pull it right back and try and get everyone on the bus and provide access points for students to kind of jump on. And at least if they can jump on, we can sort of see where they're at. So I have so I actually did it, and this is kind of what I came up with, and I think similar things probably that you've seen. Define glacier. So what is a glacier? Sketch a polar ice cap. And I think lots of kids probably do anyway. You know, you draw the mountain with the ice on top and you color it white. And so, you know, I guess my question to all of us is when we do assessment, what kinds of questions are we asking? Are we asking all mastery level questions, or are we asking kind of a nice mix of emerging, proficient, and mastery? I would argue that if we're asking too many beginning and emerging questions, those questions are not really at the curriculum. They are towards the curriculum, but they're not kind of there yet. Proficient and mastery questions, I would argue, are at curriculum. This is where a grade 8 student should be to be getting, anywhere from 50 to 75% or 75 to 100%.
Maria,
Yeah.
they're wondering, they're saying these questions are awesome. And this example is
Okay.
awesome, and they're wondering if this is on EPD or where they can access this information, if there's
So,
more of it. I know you shared your
so
slide.
thank you for that. The truth is, well, they're kind of living in different places because they're work that other teachers have done. So these are things that I've worked with like specific teachers in their context, and then I'm sort of using it. So there isn't is the answer. The idea I'm hoping is that we can take the stuff a teacher has or stuff that you already have in your resources and think about, well, where does this question live? Would it be a beginning type of question, or is it a proficient type of question? And sort of organizing when it's time for an assessment, organizing all the questions that you have along sort of that complexity line. Because if we can do that, then that's all really this. Oh, whoops, this is all that this is really kind of about. So I do have some. Is it comprehensive? No. I think the strength of this comes when you're doing it, when you're like, oh, this is a really hard question. No wonder kids, you know what I mean? It's the conversation with a colleague or me or anybody or sort of anybody who's interested in the science piece. I do have some as exemplars, but no, I don't have them done. Yeah. I did want to talk a little bit about high school. High school tends to kind of be a tough nut to crack. Often teachers are like, no, I don't have time. I don't have time, which to a large extent, they're not wrong. But I do think that it's valuable to think about this as well um, from a high school perspective. So here's a grade 10 outcome. Explain using the periodic table how elements combine to form compounds following IUPAC guidelines. So the specific outcome is predict formulas and write names. So the knowledge piece is predicting, and the skill piece is using the periodic table. If you can use the periodic table, that's the skill. It doesn't matter if you're in grade 9 or 10 or in Chem 30 or in university, that's the skill. So working with a high school teacher, we did the same thing. We have our outcome, we had a question, and we put it along a continuum where we had beginning types of questions all the way through to mastery. A student who can answer the mastery level questions should be getting an incredibly high grade in this course, and there shouldn't be any issues. And I think the power with this in high school, where there's a strong emphasis on reassessment, if a student cannot get out of proficient, there's no need for reassessment. What they need to do is master the skill and then pop themselves into the mastery column, and then they can be considered masters. Often students start to grade grub. They're like, wow, I need a 90. Or I have an 86. I need an 88. What's the difference, honestly, between an 86 and an 88? I couldn't really tell you. But if I can walk my students through mastery skills and they happen to score an 88, but they really need a 90, okay, I'm giving them a 90, whatever, right? The idea is that they have mastered the skill of using the periodic table. And if they've made a careless error because they're rushing, well, that's not really the skill I'm after. I'm after, can you use the periodic table? So I see really it's just taking the resources that you have, the questions that you have, and sorting them so that all the students can start at the beginning and they can just move along the continuum and we can see kind of where they land. So the takeaway is blueprint and organize the assessments you have by knowledge and skills. I know there's nothing groundbreaking. I'm sorry. I appreciate your time, but please let me help you if I can in any way to do these things. Here are some verbs like that help me sort of understand and kind of lay things along my continuum. And you can always use AI to support your instructional material. So if you've got some questions and you're like, oh, I don't really know, here are some good pieces. Gemini AI is really good. It's through our Google Drive. Like it's if you open the waffle, you can find it at the bottom. It's kind of useful. It functions much like Chat GPT. This translation list thing is super cool. Click on it here. I'm going to do it super quick. Check this thing out. It translates in real time. So I'm just going to change the word here to, I don't know, we'll put ionic compounds. And it just does it right away. So I like it. Okay, and I know someone's going to say, what about Tigrinya? Yeah, Tigrinya's not up yet because I'm pulling from Google Translate on this one. So unfortunately, I don't have that. So please make copies for yourself as you see fit. And I'm going to leave it. Maybe you can use this for your classrooms as well. If anything, I just want you guys to respond if you wouldn't mind, just even in the chat or in an email later. I got this yesterday, actually. What, so what, now what? What stood out for you? What could this mean for your students, and what can you carry forward? If there's anything that's that you feel moved to respond to, I'd love to hear it. I'll come back to this in a second, but I do want to be cognizant of time. I think we're sort of getting near to the end here. I just wanted to say thank you, and please reach out. I'm happy to work with all of you as however you need. Really, there's no magic bullet. There's no easy answer. I think all we can do is just sort of rethink. I don't know what the answer is. Oh my gosh, I'm sorry.
Maria,
but
you had another question in the chat if you wanted to.
Sure, I'll pop
to look at that.
I'll pop
it's
over.
From Nicole, and it's about an adapted program.
Okay. At what point would students be? Okay, so that's a great question. Based on that slide that I had, I would consider a student on adapted if they can't do questions outside of beginning and emerging. So if a student really can't get through those, can't get past the low level or the low sophisticated skills, I would consider them adapted. And so ultimately that becomes a conversation between both stakeholders, teachers, counselors, the DL teacher, and the parents, I think. And of course the classroom teacher, who probably has a wealth of knowledge of how their class is structured and what their expectations are. But I do think that if the skills in grade 8 are still at the beginning, I would consider them, I probably would consider them adapted. So, yeah. So I hope that answers your question, Nicole. And then accommodated, I guess, really accommodated is, really, we don't have a lot of accommodated things. We just can say less questions, scribe, audio, those kinds of things are considered accommodations. And I think having less questions would be considered accommodated. So instead of asking 10 questions on a quiz, maybe asking only 5, but just ensuring that there are proficient, mastery, and emerging questions on that quiz. So yeah, I hope that clarifies.
I think it did, Maria. And I think the way you laid it out, the different types of questions to ask to get to the understanding of that outcome, and the way you laid it along the continuum there, just shows how you can accommodate those different students' needs just by simply asking different types of questions, which I think is it's a skill we need to build, right? As teachers and educators, the skill of questioning.
Yeah, and I think I know we borrow a lot from elementary, where we talk about the puddle questions, the lake questions, and the ocean questions, and I think that kind of fits nicely along along that as well. It's important though that we always keep sort of we have to keep it nice and tight, because in science, much like other disciplines, it can get really complicated in a hurry. And so mastery level still has to be mastery for grade 8 or for grade 9 or for grade 10. Anyway, so thank you so much, everyone, for your time on this dark morning.